All right, ladies and gentlemen, we are going to dig a little bit deeper into our nomenclature in this lecture. Topic of conversation for this particular lecture is ternary acids and their nomenclature. Before you start this lecture, please make sure you have out a couple of different resources available to you here. Number one, you need your common ion sheet and nomenclature flowchart. And number two, you need to have out your periodic tables. So, that being said, let's go ahead and begin. Looking at our nomenclature here, we're dealing with a particular type of species here, which is referred to as either a ternary acid or an oxoacid. Those ternary acids are made up of three elements bonded together with a generic formula of hydrogen plus some nonmetal plus oxygen. And we're going to be using your nomenclature flowcharts as a step-by-step guide here in order to find the right pathway to come to the correct name for these different species. So let's go ahead and jump right into our examples. The very first example we're looking at here is H2SO4. And if you have a look on your nomenclature flowcharts, follow through with me please here, starting at the very top. The very first question on your flowchart asks, is it an element made up of only one type of atom? Obviously the answer here is no, so you can follow the pathway down on your flowchart. It is not an element. Is it a binary compound is our next question, made of two types of atoms? This is also a no, since we have three different atoms here, hydrogen, sulfur, and oxygen. Follow the no pathway. Next question asks you, is it a ternary acid, an oxoacid made up of hydrogen plus a nonmetal plus oxygen? And looking at our species here, in H2SO4, we indeed have hydrogen plus sulfur, a nonmetal, plus oxygen, which means the answer here is yes. We are looking now at a ternary acid. So go ahead and follow that yes pathway down into the next box, which says to find the parent acid on the common ion chart and determine if the number of oxygens are different from the parent. So if you can go ahead now and please flip over your nomenclature flowcharts to the front side, where we have the list of the ternary parent acids in the bottom left-hand corner of your common ion chart. Go ahead and scan through that list of the parent acids and find the species which is most similar to ours, H2SO4. And if you have a look down there, about a third of the way down, you'll notice, in fact, the very species we're looking at here is listed as the parent acid in this family. Because this is, in fact, the parent acid, that means we have nothing else to do to name this. All we have to simply do is name it off of your list of the parent acids here, which means our species, H2SO4, is none other than sulfuric acid. And we are done, easy peasy. Let's take a look now at a second example problem here, and notice again here that this puts us in the same place on the nomenclature flowchart. It's not an element, not a binary compound. It is a ternary acid made up of hydrogen plus a nonmetal plus oxygen. That is hydrogen, nitrogen, and oxygen. Which means, again, we're in the exact same place on our flowchart. So flip again over to the ternary acid parents and find the species most similar to ours, HNO2. And if you have a look on there, there is no HNO2 listed under that list of parent acids. There is, however, a species which is very, very similar here. That looks very similar to ours, HNO3, which is listed as the parent of this family, and the name of that parent is nitric acid. So what we recognize then is that we found the family, but we have an acid which is different from the parent of that family. So the number of oxygens is different, which means the answer to our question on the flowchart there, if the number of oxygen is different, is definitely yes. So on your flowcharts then, follow the yes pathway down to the bottom right-hand corner of that flowchart. And you'll notice here are our naming conventions for naming ternary acids with different numbers of oxygens than the parent. We name the compound according to the following conventions. If there is one more oxygen than the parent, we add the prefix per to the parent acid name. If there's one fewer oxygen than the parent, we're going to change the suffix of the acid from ic to us. And if there are two fewer oxygens than the parent, we're both going to change the suffix from ic to us of the parent acid, and we're also going to add the prefix hypo to our parent. So looking now at our species, HNO2, the parent acid, HNO3, has one more oxygen than our species, so we have one less oxygen than the parent. So given that HNO2 has one less oxygen than the parent, we're going to go ahead and name it according to our conventions. We're going to take the name of the acid, which was nitric acid, change the ic to us, which means this now becomes nitrous acid. And we're done with our second example. Now go ahead and move on to third example right here. This next species is HClO4. Again, recognize that this is hydrogen plus a nonmetal plus oxygen. Hydrogen, chlorine, and oxygen. This is again a ternary acid. Find the parent of that ternary acid on your common ion sheet in the bottom left-hand corner. And you'll notice that the parent acid here is HClO3. The name of that parent is chloric acid. And recognize again now that we have a different number of oxygens than our parent. So with a different number of oxygens than the parent acid right here, we're going to again look on our naming sheet here, find on the flowchart for the species which has one more oxygen than the parent, since HClO4 is up one oxygen here. We'll notice here that all we need to do is add the prefix per to the parent acid name, which implies therefore HClO4 is none other than perchloric acid. And one final example on this sheet here. Take a look at the bottom. We have one final species, H3ASO4. And again, recognize that this is another ternary acid here, where we have hydrogen plus a species which is not a metal, in this case, the metalloid arsenic, plus oxygen. So again, we've got a ternary acid here. Find the parent on your parent acid sheet. And if you have a look down there, about 2/3 of the way down your list, we have H3ASO4, which is named arsenic acid. And now to name our acid, which has one fewer oxygen than the parent, you can look to our naming conventions. All we have to do then with one fewer oxygen is change the suffix ic to us, which means again now we have arsenous acid. All right, so there is naming some ternary acids. Let's go ahead and move on to a second page right here. A couple more examples. Going the other direction, this time giving you a name and asking you to provide the formula of this species. First example is hyponitrous acid. Go ahead and start by looking on your list of the parent acids here and find the acid that looks like it shares the same root word as our species. That is the nitric acid family. And that nitric acid has the formula HNO3. So once we've identified the parent acid, now all we need to do is to look to our prefixes and suffixes to determine what acid we are dealing with. Our acid has both the suffix us and the prefix hypo, which implies, again, looking at your nomenclature flowchart in the bottom right-hand corner, that our species has 2 fewer oxygens than the parent acid, which implies, therefore, if nitric acid is HNO3, hyponitrous acid must therefore have 2 fewer oxygens. It is HNO. And one second example here, a species here, periodic acid. Again, we've got a parent acid listed on your list of the parent acids on your nomenclature flowchart. Sorry, on the common ion sheet. Have a look there and find the parent here of the family, which is iodic acid at the very bottom of that list. Iodic acid has the formula HiO3. And again, to determine what our species is, take a look again in the prefixes and suffixes. We now have the prefix per for our species, which implies, looking at again at your flowchart, the prefix per is added to an acid if it has one more oxygen than the parent. Therefore, for the parent acid HiO3, our acid, periodic acid, would have the formula HiO4. So just in summary again here, have a look at the overall key to naming ternary acids. This is the same information which is contained on your common ion sheet. If you have the prefix per, suffix ic, that implies you have one more oxygen than the parent. If the suffix is -ic without the prefix -per, that is the parent acid of the family. If you have the suffix -us, that implies one fewer oxygen than the parent. And if you have the prefix hypo and the suffix -us, that implies two fewer oxygens than the parent. And using this as a guide, we could then go through the entirety of a family. If I take the species HClO3, this is the parent acid listed on your sheet there as chloric acid. And now we can name the rest of the species within the family. If I have HClO4, that again has one extra oxygen on it, we're going to go ahead and add the prefix -per, chlor, and then the suffix -ic acid. Taking away one oxygen from the parent would give me HClO2. And according to our conventions, with one fewer oxygen, we add the suffix -us to our parent. So we have now chlorus acid. And then finally here, the species HClO, with two fewer oxygens than the parent, would get both the suffix -us, and also the prefix hypo, which means the species HClO is none other than hypochlorous acid. So there are your naming conventions for naming ternary acids. Please make sure that as you go to complete your homework assignment on this particular set of problems, that you keep out your nomenclature flowchart and your common ion sheet to assist you in completing these problems. That concludes our lecture on naming ternary acids.